Hello, everyone. So this is number 25. So three concentric circles have a radius 1, 2, 3. An equilateral triangle with the side S is on each vertex of the circle, on one vertex on each circle, and we want to find the S squared. Basically, I just add this to problem, so this wasn't part of the question. So I draw three circles that is centered as origin, and we are told that there is like a equilateral triangle where we can actually um, take 1 point on each circle to draw it. So I'm gonna choose the 1 point like on here. So I'm gonna say this is A, and I'm gonna choose the second point somewhere that will be. I mean, I'm gonna choose the like when you draw the equilateral triangle. Let me kind of make that. So like if you have equilateral triangle somehow, and you should have intersection of the medians or altitude or the angle bisector intersecting at this point that's called centroid, and then that will be all perpendicular to its sides, right? Because of the equilateral triangle. And I'm going to try to make the centroid on the x-axis so we can kind of make some sort of symmetry helpful. So for that reason, let's say my second like I mean my 1 point is like, I mean, the centroids will be on these lines, maybe somewhere here. So to make that like useful, so I'll just choose my point B, let's say right here. Okay, so actually I may not be having this one. Okay, and then I'm gonna choose the C is somewhere right here, and then A might be, let's say, somewhere here. I'm gonna choose this is A. This is B, this is C. So again, the goal is just to draw this equilateral triangle to make um, the centroids on the x-axis. Okay, so that looks like we will have something like this. It doesn't have to be actual x-axis. I'm just drawing that is parallel to x-axis. Okay, so then in this case, this is my equilateral triangle. If I draw like the altitude, my centroid will be somewhere here. So if I want to say my centroid is something somewhere here, so that's my G. I'm going to call this is A comma B. And that is just the value of those AB, right? Coordinates. And if I want to find the like the distance from the centroid to the each vertex, I'm going to call that's like T. So we do have that T is also from here to here or from here to here as well. So those are also T's. And we want to find the coordinates of ABC. So that will be like T units to the right from the point A. So that should be A plus T comma B. So I can write this as A plus T comma B. Okay. And if I want to find the B as well, so the B will be like, this is like T, and then this has to be T over 2. And then there's a 36 to 90 triangle right here. So, and then that means this will be like T root 3 over 2. So in this triangle, because this is like T over 2, it's opposite to 30 degrees. So that means this has to be T root 3 over 2. And the same thing happening right here. So that means B will be like this much higher than B. So, but we want to do T over 2 units to the left from the centroid. So that should be A minus T over 2, comma, like B plus T root 3 over 2. Okay. And then if I use the same logic with C, so I'm going to find that will be A minus T over 2 because we are still to the left. And then comma B minus T root 3 over 2. Okay, so we have these 3 points. So now we can maybe write the distances because we are given that these when you take these distance they are all r, okay, but we know the distance from the centroid to this each circle we can draw that like distances, make a three equation basically. So using the 1, 2, and 3, right? So because we can say that the distance from the center to like the point A is gonna be 1, and then distance from the center to B is 2, and then maybe C is 3. So because of the given numbers, right? So with that in mind, so I can say A plus T squared plus B squared is equal to 1. That was the first distance. And the second one is for B. So I'm going to say A minus T over 2 squared plus B plus T root 3 over 2 squared. And then that will be equal to 4. And then for C, so you got A minus T over 2 squared plus B minus T root 3 over 2 is equal to 9. And then I'm going to call this is 1, 2, and 3 as the equation. So I hope that was clear. So if this is clear, the rest is kind of a bit easier. The rest just algebraic work basically. So let's clean these first. So one thing I'm going to do, I'm going to try to solve the system because we have three equations and then we have three unknown. So we should be able to solve this one. So if I want to like take maybe the last two equation, I'm going to take the 3 minus 2, these equation, because this guy the same, so this will cancel. When you expand this, B squared will cancel. When you expand T root 3 over 2 squared will cancel. From this guy, you'll get 2 times B times this, which will give us negative B2 root 3, but you will subtract this from that, so you should get like minus 2 root 3 T times B is equal to 9 minus 4, which is 5. So the TB or BT, whatever, is equal to 5 over negative 2 root 3. I'm going to leave it as it is for now to see if we need to simplify. And now we want to find something like similar to this one. So maybe I can find AT because A is another variable. So like, but if I subtract the some other ways, that there's no really easy way to get only one like term like this. So maybe you can add like the 2 and 3 and subtract the 1, but when you subtract 1 itself, so you just still get some a squared, like a squared minus a squared, just a squared. But maybe I can multiply the first by 2 and subtract from the other 2. That might be useful. So what I'm trying to say, let's do this. 3 plus 2, or 2 plus 3, minus 2 times the equation 1. So if I do this, you know, a squared plus a squared, that's 2a squared. And then you got a squared, but you multiply by 2, and then those a will cancel. And the same happening with the b's as well. So the middle term, let's be carefully. So when you multiply these, you got 2ab, right? 2 times a times this, which is going to be negative a times t over 2 times 2, which is negative at. But that's also negative at. That's negative 2at. And then that will be 2at, but that's going to be multiplied by 2, which is going to be 4at, but we subtract that, so you'll get negative 6at. And if you don't see immediately, so I'll say, go ahead and maybe write that separately, and to see that's really the case. And then you got t squared over 4, t squared over 4, that's t squared over 2, but that will be t squared, but you multiply by negative 2, subtract from t over 2, so keep that in mind. So like negative, t squared over 2 minus 2t squared. But at the same time, you got 3t squared over 4, 3t squared over 4, that's 3t squared over 2. And then when you add with that, that will be 4 over 2, which is 2. That will cancel, which means there will be no t terms left over when you combine these as well. And then with b's already canceled, and then the middle guys right here will be also cancel each other when you add them. So that means this is the only term will be actually left over when I do this one. So that means 9 plus 4 is 13, minus 2 is 11. Okay, so that means AT is equal to negative 11 over 6. Okay, so that is something. And then if I want to find another equation, So what I will do now, I'm going to add all these three. So if I add 1 and 2 and 3, so we can kind of do the algebraic work, but if you do add them all together, so you are going to end up getting a squared plus b squared plus t squared is equal to 14 over 3. So again, if you don't get it, so take a look at it and see if you can carefully do the work, but that will be this one. And then we have this one, but now we do want to get the, the t somehow, because t will be telling us the side line of the triangle. So, but I have at and bt, maybe I can multiply by this t squared. So that should be a squared t squared, b squared t squared, and then t to the fourth power is equal to 14t over 3. So when you plug these guys, like at is given, so you got 121 over 6, and then bt is like 25 over 12, and then you got t to the fourth equals 14t over 3, so t squared actually. And then you can do substitution right here, like t squared is equal to t, like, or x, and then solve this for quadratic. When you do so, you actually get t is equal to, t squared is equal to 7 over 3. If this is the 7 over 3, but at the same time t is like this one, that means when you combine it with the t over 2, so you got t plus t over 2 is 3t over 2. That's going to be height. So if you divide by root 3, so you get one leg, so that will be root 3 over 2t, but that is times 2, so you will get just 3, let me say, like, that's the height, which is going to be divided by root 3, so you will get root 3t over 2 for a leg, and then you multiply this by 2, so you got t times root 3. But we are looking for the t square, so, but this is the side length, so if I square this one, so you got 3 t squared, and then t squared is 7 over 3. We're going to multiply by 7 over 3, so you got 3 times 7 over 3, which is just 7. So that was like a bit challenging, so I kind of skipped some of the algebraic work. So if you, again, didn't get those parts, so I highly recommend you to try to get all of these kind of side work that I just skipped. So I hope that will be able to easier for you to do as well. Anyway, I'll see you in the